Okay, in this section we are going to talk about using proportional relationships. First vocabulary word is indirect measurement. Indirect measurement is any method that uses formulas, similar figures, and proportions to measure an object. So it is any method that uses formulas, similar figures, and proportions to measure an object. When dealing with proportional relationships, we also have another vocabulary word that is a scale drawing. A scale drawing represents an object as smaller or larger than its actual size. So it represents an object smaller or larger than its actual size. Okay, and with a scale drawing, we have also this thing called the scale. The scale is actually the ratio of the length of the drawing to the length of the actual length. So the scale is the ratio of the two. Let's take a look at an example. A student wanted to find the height of a giant inflatable ape. She measured the ape's shadow and her own shadow and then made a diagram. The height of the student was 5 feet 2 inches. What is the height of the ape? What we have to do in this situation is we are trying to find the height of the ape. So we're going to call that x. And we know the height of the student is 5 feet 2 inches. So in order to do this problem, the first thing we must do is we must have common units. So what I'm going to do is I'm going to convert everything to feet. This is 3 feet, 10 feet 6 inches, because 6 inches is half of 12. This would be 10.5 feet, because 6 over 12 is 0.5. And then 5 feet 2 inches would actually be 5.16 repeating feet. And the way you get that is you take 2 and divide it by 12 to get the 0.16 repeating. Once you have this, then you can set up a proportion. So you take one side on the original figure here. So I'm going to take the shadow, 3. That corresponds to the shadow of the ape, which is 10.5. And you can either put the 3 on the top or the bottom. So we'll go 3 over 10.5. And once you have the 3 on top, you then must write its another side distance on top on the other ratio. So this other side length is 5.16 repeating over the height of the ape, which is x. Once you have it set up like this, you then are going to cross multiply. So if you just take 10.5 and multiply by 5.16 repeating, you get 54.25, and that's going to equal 3x. Then to get x alone, you divide by 3, and when you get that, you will know that the height of the ape is about 18.1 feet. Let's try another example. A student who is 5 feet 6 inches tall measured shadows to find the height LM of a flagpole. What is LM? So the first thing we're going to do is we're going to call LM x, and from here we're going to set up proportions. So the first thing I'm going to do is pick a side length. I'm going to start with 5. 5 corresponds to 14 feet 2 inches. So the first thing I'm going to do there is I'm going to figure out what 14 feet 2 inches is. And in feet, that is 14.16 repeating feet. So 5 to 14.16 repeating equals, if you go back to your original picture, 5 feet 6 inches. Because 6 inches is a half a foot, that becomes 5.5. And that corresponds to x. Another way of doing this is you could have also converted all the dimensions to inches. To solve this, we're going to cross multiply. So if we go 14.16 repeating times 5.5, we will get 77.916 repeating. That's going to equal 5x. To then get x alone, we're going to divide by 5. And x is going to equal approximately 15.583 repeating feet. In our next example, we're doing the same thing with similar figures, except in this case we don't have a picture. It says, on a Wisconsin road map, Kristen measured a distance of 11 1/8 inch from Madison to Wausau. The scale of the map is 1 inch, 13 miles. What is the actual distance? The first thing I'm going to do is I'm going to take the actual scale of the map and write it as a ratio. 1 inch is 13 miles. Now the 1 represents the scale, the 13 represents the actual distance. We're going to set that equal to a proportion. If you look up above, Kristen measured a distance of 11 1/8 inches from Madison to Wausau on the map. So, because this is on the map, that is our scale. So what I'm going to do is I'm going to convert this and make this 11.125. I did that by dividing 1 by 8. Because that is my scale, I'm going to put that on top. I'm going to put the x on the bottom to find and calculate the actual distance, and then we're going to cross multiply. So if you take 13 times 11.125, you will get 144.625. And then that's going to equal x. So in this case, we found our answer, and we don't even have to divide because 1x is the same as x. So our actual distance will be 144.625 miles. In our next situation, we have Lady Liberty holds a tablet in her left hand. The tablet is 7.189 meters long and 4.14 meters wide. If you made a scale drawing using the tablet, saying 1 centimeter is 0.75 meters, what would the new dimensions be? The first thing I'm going to do is I'm going to take this ratio and write it down. So the scale is the centimeters, and the 0.75 meters is the actual distance. So the first proportion I'm going to set up is we're going to have to do 2 proportions here, one to get the new length and one to get the new width. So because the tablet is actually 7.189 meters long, that's going to go on the bottom, and x is going to go on top. When you cross multiply, you get 0.75x equals 7.189. You then divide by 0.75, and when you do that, you get an answer of approximately 9.585. And because we're trying to find the scale, that will be in centimeters. You then take your original ratio again, and this time instead of doing 7.189, we now must find the new width. So we're going to make that on the bottom, 4.14. We're again going to cross multiply. 0.75x equals 4.14. And when you divide, you will then get 5.52 centimeters. So that would be your new scale drawing dimensions. All right, if you flip the page, in our next example, we are dealing with a rectangular central chamber of Lincoln Memorial. It is 74 feet long and 60 feet wide. We have another scale drawing here. It's 1 inch to 20 feet. How long and wide are the new drawing? All right, we are again taking this ratio. This is the scale. This is the actual. Because we are trying to find both the new length and the width, we are going to have to do this proportion twice. The first thing I'm going to do is I'm going to take the length. Because it's the actual length, I'm going to put the 74 on the bottom. And when you cross multiply this, you get 20x equals 74. When you divide 74 by 20, you get 3.7. Once you have your new length, we then have to get our new width. So we take 1 over 20 again, and this time our original width is 60 on the actual Lincoln Memorial, and we're going to try and find what it is on the scale. If you cross multiply, you get 20x equals 60. When you divide by 20, x is going to be 3. So your new dimensions on the scale are going to be 3.7 inches by 3 inches. Next, we're going to talk about similarity, perimeter, and area ratios. If you take a look at these two triangles, ABC is similar to DEF. There are kind of 3 things we're going to talk about. If you found the similarity ratio of these triangles, 5 over 10, 4 over 8, and 3 over 6, all are going to equal 1/2. If in turn you are trying to find the perimeter of this triangle is 12, the perimeter of this triangle is 24. If you take the perimeter of this one over this one, excuse me, you get 1/2. So if you notice, the similarity and the perimeter ratio are the same. Now, if you take the area, the way you get the area of a triangle is 1/2 base times height. So if you go base times height, get 12, cut it in half, your area would be 6. 8 times 6 is 48, cut in half would be 24. If you reduce that, your area ratio is 1/4. And if you notice, the similarity and the perimeter ratios are the same, but the area ratio is squared. If you take the similarity ratio and square it, you will get the area ratio. Okay? From that kind of similarity statement and example, there's a proportional perimeters and areas theorem. If the similarity ratio of two similar figures is A over B, then the ratio of their perimeters is A over B, and the ratio of their areas is A squared over B squared, or A over B squared. Let's take a look at our first example. It says, given that triangle RTS and triangle UWV are similar, find the perimeter P and the area A of the new triangle. All right, the first thing we're going to do is we are going to start with our similarity ratio. The way you would get your similarity ratio is you would take 16 and you would divide it by 20. Now, what we're going to do is we're going to set that proportion equal to what the perimeter would be in the triangle that is given. Because the perimeter is given in the triangle that is 16, we are going to put 36 on top here because it matches the 16 triangle, and we're going to try and find the perimeter here and call it P. Because the perimeter ratio and the similarity ratio is the same, we do not have to do anything with this 16 over 20. If you then cross multiply, and you go 20 times 36, you get 720. That equals 16P. If you take 720 and divide it by 16, your new perimeter will be 45 feet. Now, on the other hand, if we are trying to find the area, we're going to still start with that similarity ratio, but we just learned that the ratio of the areas is the similarity ratio squared. So what we're going to do is we're going to square this time to get our area. Because our area was still given in this triangle, we're going to put 48 on top here, and we're going to try and find A. But before we do that, we must actually square the similarity ratio. So, there's a couple ways you can do this. One way is to square the top and the bottom and cross multiply. Another way is to simplify and then square. Some people like to simplify first and then square. 16 over 20, 4 goes into here 4 times. It goes into there 5 times. And then you can square that ratio. So you will get 16 over 25 equals 48 over A. And when you do this, you cross multiply. 25 times 48 is 1200. 1200 equals 16A. If you then divide by 16, your new area will be 75 feet squared. And if you would have done it the other way, you could have squared the 16. 16 squared is 256. 20 squared is 400. If you would have set this up without simplifying it first, if you go 400 times 48 and then divide that by 256, you would have got the same area. Let's try another example. First thing we're going to do is write down the similarity ratio between these two triangles. So we have triangle EFG and HJK. And the first thing we're going to do is find the similarity ratio. So the side length of this first triangle is 8. The side length of this triangle is 24. The first thing we're going to do this time is, how about if we reduce our similarity ratio? 8 over 24 reduced is 1 over 3. So let's start with 1 over 3. We're going to try and get our perimeter first. Because they give us the perimeter here, we're going to put the 27 on the top because it represents the triangle that was originally 8, which is now 1. And we don't know the perimeter here, so we're going to call it P. So in this case, if we cross multiply, if you go 3 times 27, you will get 81. So P is going to equal 81 meters. So our new perimeter of our new triangle will be 81. In order to get our new area, we take our similarity ratio, but this time we have to square it and set that equal to our area. The area of this triangle was 32. We're trying to find the area of this triangle, so there's our original setup. If you square the 1 and the 3, you get 1 over 9. 1 squared is 1. 3 squared is 9. Equals 32 over A. When you cross multiply, 9 times 32 will get you 288. So 288 equals A. So our area will be 288 meters squared. In our last example, we have two rectangles. We are going to try and find the perimeter and area of the second rectangle. So this time the first thing we're going to do is we're going to set up our proportion, 21 over 14. The first thing I think we would want to do is reduce that. 7 goes into 21 3 times, goes into 14 twice. So our similarity ratio will be 3 over 2. So I have 3 over 2 equals, because our perimeter is given on our first one, the one that represents the 21 and the 3, we put 72 on top and P on the bottom, and then we're going to cross multiply. 72 times 2 is 144. That equals 3P. When you divide by P, our answer will be 48. So our new perimeter will be 48 centimeters. We're then going to do the same thing for our area. We're going to take our perimeter ratio and square it this time and set that equal to 315 over A. When we do that, 3 squared is 9, 2 squared is 4, and now we're going to cross multiply here. If you take 315 times 4, you get 1,260. That equals 9A. If you divide by 9, your new area will be 140 square centimeters. All right, if you flip your page, we are now going to take a look at the last page. On the last page, we're going to talk about perimeter and similarity ratios and area ratios. We know that the perimeter and similarity ratio are the same, and we know that the area ratio is the square of the similarity and the perimeter ratio. So in our first example, the perimeter ratio is 2 to 3. What is the similarity ratio? Because the perimeter and the similarity ratio are the exact same, if the perimeter ratio is 2 to 3, the similarity ratio will also be 2 to 3. Okay, on the next example, in this case they give us the perimeter ratio is 3 to 5. We need the new area ratio. So in this situation, because the perimeter ratio and similarity ratios are the same, if the perimeter ratio is 1/2, the similarity ratio will also be 1/2. In our next example, we are then talking about the perimeter to the area. Because we know the area ratio is the square of the perimeter ratio, what we're going to do is we're going to take the perimeter ratio and square it, and that will get our area ratio. Excuse me. In the next example, we are then looking at perimeter ratio to area ratio again. Because we know the area ratio is the square of the perimeter ratio, we're going to take the perimeter ratio, square it, and then that will get our area ratio. In the next example, we are given the area ratio, and we need to find the perimeter ratio. Because the area ratio is the square of the perimeter, what we want to know is we want to know what squared gives me this. So if we want to know what squared gives me this, the way we can undo this is by taking the square root of it. So the square root of 49 is 7. The square root of 81 is 9. So our perimeter ratio will be 7 over 9. It says the ratio of the area of ABC to area DEF is 25 over 81. This question should say what is the perimeter ratio of triangle ABC to DEF. So again, if we're given the area and we need to kind of work backwards to the perimeter, what we have to do is from here to here you square it. So to go from area to perimeter, we're going to square root it. So our ratio here would be 5 over 9. Then we have our last example. The ratio of the area of triangle ABC to the area of triangle DEF is 64 over 121. We need to find the similarity ratio. So again, the same as perimeter. From here to here you square it, so from here to here you're going to square root it. So the square root of 64 is 8, and the square root of 121 is 11.